Hello students, my name is Professor Muhammad Asim and we are doing additional mathematics. Additional mathematics for those who are doing IGCSE which have syllabus code 0606 and for those who are doing CIE O level which have syllabus code 4037. So both kind of students can get equal benefits from this course. As you know, students, we have started chapter 2 from this book. Name is Simultaneous Equations and Quadratics. And we have finished exercise 2.1 completely, all questions with all parts. And we started exercise 2.2, did first 13 questions from this exercise. So those students, my advice for those students who are watching this lecture first time, kindly go to my playlist where you can see the folder name is add math. You can, in order to get good command from for this topic, kindly watch previous lecture first. Okay, so after question number 13 which we did in last lecture, we are going to start question number 14. Let's start. The function f is such that fx is equals to 2x square minus 8x plus 3. Part A. Write fx in the form of 2 into x plus a whole square plus b, where a and b are constants to be found. Very easy part. We did lot of questions for this type. Part A. Fx is equals to 2x square minus 8x plus 3. In order to convert this one into perfect square, the requirement of the question, we should have the coefficient of x square is 1. So we have to take common the coefficient of x square from first two terms. So I am taking common 2. It will become x square minus 4x and this plus 3 remains plus 3. Now apply the second result which you can see on top of the screen. X square minus 2 dx is equals to x minus d whole square minus d square. So first we have to take the coefficient of x, that is 4, divide this coefficient by 2, always divide by 2, then 2 into x, write x minus 2 whole square minus 2 square, bracket close, and this plus 3 remains plus 3. After this, 2 into x minus 2 whole square minus 2 square is 4, bracket close, plus 3. Now multiply this function by 2. So 2 into x minus 2 whole square and 2 into 4 is 8 plus 3. So 2 into x minus 2 whole square minus 8 plus 3 is minus 5. So this is the requirement of question part A. Our answer is 2 into x minus 2 whole square minus 5. So this is our answer. Come to part B. What is part B? Write down a suitable domain. Write down a suitable domain for f so that f inverse is exist. Very easy question. What is inverse function? A function has inverse if it is a 1-1 function. If it is a 1-1 function, or you can say 1-to-1 function. 1-to-1 function means for single input there is always single output. This is the definition of 1-1 function. So if a function is 1-1, then its inverse is exist, otherwise not possible. So the question is, write down a suitable domain for f so that f inverse is exist. What is our answer? Final answer of part A: 2 into x minus 2 whole square minus 5. So student, if we put the value of x is greater than or equals to 2 in above function, then the function has an inverse, or we can say the f inverse is exist, otherwise not. What does it mean? If we put 2 in the function, you can clearly see that I can show 2 minus 2 whole square minus 5. 2 minus 2 is 0, and 0 multiplied by 2 is 0. The value is minus 5. So for one single input, we are getting single output. And if I take the value of x is 3, for example, so 3 minus 2 whole square minus 5. 3 minus 2, 1 square is 1. 1 into 2, 2. 2 minus 5 is minus 3. Again, I am seeing that one single input, we are getting single output. But if we put the value of x below 2 or less than 2, the function will no more 1 1. So in order to keep the function 1 1, we should have the domain of x, domain of the function must be equals to 2 or greater than equals to 2. Because if I take, for example, if I take minus 1, see this, minus 1 minus 2 whole square 2 minus 5. Minus 2 minus 1 is minus 3. Minus 3 square is 9. 9 into 2 minus 5. 2 nines are 18. 18 minus 5 is what? 13. But this value is 13. And if we put x is for example 5. If we take x is equals to 5, so 2 into 5 minus 2 whole square minus 5. 5 minus 2, 3. 3 square is 9. 9 minus 5. 2 nines are 18. 18 minus 5 is, again we are taking 13. So it shows that for x is equals to minus 1, the output is 13, and for x is equals to 5, the output is 13. Therefore, if we take the values of x which is less than 2, the function will no more 1 1. Hence the inverse is not exist. Therefore, we should keep the values of x should be greater than or equals to 2. So this is our final answer. X greater than equals to 2. This is just explanation, not the part of the question. Not the part of the question. But I hope you understand why we are taking the values of x from 2 to greater than 2. Okay student, I hope you understand question number 14. Let's start question number 15. This is question number 15. Fx is equals to 4x square plus 6x minus 8, where x is greater than equals to m. Find the smallest value of m for which f has an inverse. Same question just like question number 14. But first we have to convert this given function in terms of or apply the completing square method. 4x square plus 6x minus 8. So in order to have the coefficient of x square should be 1, I am taking 4 is common from first two terms. So this is x square and this should be 6 upon 4x, and this minus 8 remains minus 8. Cancel this by 2, 2 3 is 6, 2 2 is 4. So 4 into x square plus 3 upon 2x minus 8. Now focus on the coefficient of x, which is 3 upon 2. So always divide the coefficient of x by 2. 3 upon 2 divide, converting into multiply should be 1 upon 2. 3 ones are 3, 2 twos are 4. So 4 into, sorry, 3 upon 4, not 4. 3 ones are 3. I am sorry, 3 ones are 3, 2 twos are 4. 3 upon 4. So x minus 3 upon 4, I am applying x plus, I am applying result number 1, which you can see on top of the screen. X plus 3 upon 4 square minus 3 upon 4 square, bracket closed, and this minus 8 remains minus 8. Now 4x plus 3 upon 4. 3 upon 4 is 0.75 square minus 3 upon 4 is 9 upon 16, bracket close, and this minus 8 remains minus 8. Now multiply this 4 by the whole bracket. You will get x 0.75 whole square minus 4 into 9 upon 16. 4 into 9 upon 16 is 4, 4 is 16. The answer is 9 upon 4, and this is minus 8. Finally, x plus 0.75 square minus 4 8s are 32, 32 plus 9 is 41. So 41 upon 4. Okay. Now it is reduced completely in terms of completing square, perfect square. What is the requirement? Find the smallest value of m for which f has an inverse. What should be the smallest value of x? Clearly, what is inverse function? A function has inverse if it's 1 1 function. And what is 1 1 function? For every single input there should be single output. Therefore, if we take the value of x is minus 0.75 and put this minus 0.75 in the question, we will get minus 0.75 plus 0.75 cancel. The answer will be 0, 0 square is 0, 0 4 is 0. So for this value of x, we will get minus 41 upon 4 answer. Okay, I am showing the working. Put this 4 into minus 0.75 plus 0.75 whole square minus 41 upon 4. We can cancel this. The answer is 0. 0 minus 41 upon 4 is minus 41 upon 4. So x means m, because in the question x is greater than equals to m. So m must be minus 0.75. This is the smallest value. Below this value, the function will no more 1 1, and obviously the inverse doesn't exist. So m is equals to minus 0.75 is our answer. Hope you understand. Moving towards question number 16. This is question number 16. The first requirement is same, part A. Fx is equals to 1 plus 4x minus x square for x greater than equals to 2. This is the domain. Please keep in mind the value of x is domain and the value of fx or y is range. So fx, given fx is equals to 1 plus 4x minus x square. Express part A. Part A is express 1 plus 4x minus x square in the form of a minus x plus b whole square, where a and b are constants to be found. Very easy. First write minus x square first, then plus 4x, then plus 1. Taking minus sign, minus 1, or you can say minus sign is common outside. Minus minus plus x square minus plus minus 4x. Bracket close. This plus 1 remains plus 1. Focus on the coefficient of x, that is 4. Divide the coefficient of x by 2. We will get 2. Therefore minus, bracket close, x minus 2 whole square minus 2 square plus 1. I applied the second result, which you can see on the top of the screen. X square minus 2dx is equals to x minus d whole square minus d square. Okay, so minus x minus 2 whole square minus 2 square is 4 plus 1. Multiply this minus sign by the whole bracket. We will get x minus 2 whole square minus minus plus 4, and this plus 1 remains plus 1. So minus x minus 2 whole square, 4 plus 1 is 5, and write 5 minus x minus 2 whole square. So this is the requirement of part A, question number 16, answer. Okay. Part B. Part B is find the coordinates of the turning point of the function fx, stating whether it is a maximum or minimum. Very easy. In order to find the turning point, our equation should be in the form of y is equals to a into x minus h whole square plus k. So write our answer of part A again, and this time we are writing square first and then this constant after this. Now compare this answer by the general equation y is equals to a into x minus h whole square plus k. Clearly h is equals to 2 and k is equals to 5. And we know that turning points or stationary points or vertex are HK. So our H is 2 and K is 5. This is the answer of part B, first part. Because we have to find the function is maximum or minimum. Very easy. This constant A, this constant A will give you the information whether the function is maximum or minimum. So if A is greater than 0 means positive. The function is minimum. And if A is less than 0, that is the value of A is negative, the function is maximum. So our answer show that the value of A is -1. So we can say fx is maximum. This is the answer, complete answer. The turning points are 2, 5 and the function is maximum. Last part, C. Explain why fx has an inverse and find an expression for f inverse x in terms of x. Very easy. There are two parts in part C. First, he asks you that fx has an inverse. What is the reason? What is fx? fx is our fx is from part A answer 5 minus x minus 2 whole square. And in the question, the domain is given x is greater than equals to 2. It means we cannot take the value of x which is below 2. So obviously, because there is the restriction, the value of x is always greater than and equals to 2. Hence, this shows that if we put every single value, of x, we will get single value of y, because the domain is x is greater than equals to 2. Domain is not a real number. So what is the answer? Answer is, because I am writing because it is a 1-to-1 or 1-1 function. This is the reason. Explain why fx has an inverse, because it is a 1-1 function. Now, the next requirement of part C is find an expression for f inverse x in terms of x. Very easy. Recall exercise 1.5 where we learn to find how to find the inverse. So take the answer of part A again. Y is equals to 5 minus x minus 2 whole square. The first step is to replace x to y and y to x. So this y becomes x and this x becomes y. The second step is to make y is the subject of the given formula. So I am shifting this y minus of y minus 2 whole square over here. It will become y minus 2 whole square. This 5 remains 5 and I am shifting this x on this side. It will be minus x. taking square root on both sides. So it will be y minus 2 whole square, because square and root cancel, and 5 minus x root plus minus sign. And y is equals to, shift this minus 2 on other side, it will become 2 plus minus 5 minus x root. Okay, and finally replace this y by f inverse x. It will be 2 plus minus 5 minus x root. This is the answer, complete answer of part C. The first part of part C is explained why fx has an inverse. The answer is because it is a 1-1 function as the domain is given. And the second part of part C is find an expression for f inverse x in terms of x. Our answer is f inverse x is equals to 2 plus minus square root of 5 minus x. So student, this is our today's class, where we have finished the whole exercise 2.2. You can see there are so many questions, total 16 questions, and each question have many parts. Like in question number you can see part A to F, in 2 part A to H, 3 part A to H, 4 part A to H, so many parts. And you are witness that I did each and every part of this exercise. Not only this exercise, previous exercises also. What next? Our next topic will be graph of y is equals to absolute function, fx, absolute sign, where fx is quadratic. So we will learn in next lecture. And how many questions in exercise 2.3? There are 7 questions with many parts. I promise you I will do each and every question from this exercise 2.3 with each and every part. There is no YouTube channel, students, where a teacher do each and every question, each and every part. So after this exercise, if you feel any problem or if you want to ask any question, kindly write in comment box. I promise I will help you. And if you think that my videos are helping you, kindly do subscribe my channel and press the bell icon button, so that whenever I upload my lectures, you will get the notification. Kindly don't restrict my videos to yourself only. Share as many as you can. Okay, students, good luck for next lecture.